looking at a slightly different situation. You'll notice I have a boat that is 800 kilograms. It starts at 50 kilometers per hour, slows to 20 kilometers per hour as after it cuts its engines, and it'll drift into the harbor. So that means the drag of the water will slow it down. The acceleration occurs over 30 meters. And I want to know what the friction force involved is. So to do this, I need to start by actually changing my units, because you'll notice my distance is in meters and my velocities are in kilometers per hour. So I'm going to change those first. So I'm going to start by changing those. So V1 is 50 kilometers an hour. And remember, I'm going to divide by 3.6, the magic number, in order to find my meters per second. So that will be 13.89, we'll say. I'm keeping a couple of extra digits. I want to make sure that I keep some extra digits for rounding purposes, right? This is not my final answer, so you always keep a couple extra to the end. And then my 20 kilometers per hour, again, divide by 3.6, and I will get 5.56 meters per second. Excellent. So those are set. Now, what I want to do with these is I want to use these to find my acceleration, because the trick here is if I know the acceleration, I can find the net force, and that gets me over from kinematic equations to forces. So I want to find what that acceleration is. And I can do that now because I now have everything in matching units. How pleasant. This will also give me my answer in meters per second squared when I find my acceleration, which is what I want when I'm dealing with forces, right? So I will put in my numbers and my other number. There we go. And plus 2 times my A, which is what I'm trying to find, and it happens over 30. So I'll do my math, I'll rearrange the whole lovely thing and get an acceleration of negative 2.70. Now I am keeping an extra digit. You'll notice my final sig figs will be 2, but I can keep this extra digit because I'm not done yet. This is not my final answer. I got a negative acceleration, which is excellent. I should get a negative acceleration because I am dealing with something slowing down, so it's very logical. Now I just have to think about my net force. So my net force is going to be equal to just my friction force. Now, why is that? Now, my friction force will be negative. Well, when I'm slowing to a stop, right, no engines are going anymore. So it's only going forward because of its own inertia. So it doesn't have an applied force. It just has its friction force, normal force, and gravity, and only the friction force is acting in the direction of motion. So that's the one we're worried about. So that means that I know that my mass times my acceleration, I'm just substituting the equation in for net force, is going to be equal to my negative friction force. And I can then put that in, right? Because I know my mass of my object. They said it was an 800 kilogram boat. I found my acceleration just a moment ago, and that will give me what my friction is. Now you'll notice the negatives are going to go away, and this will just give me the numerical value for friction, which is what I'm looking for anyway. So this would be my numerical value for friction. Now this is where I do have to consider my sig figs, because I don't get to keep all these digits. I have to round this, so I am going to round it to 2.2 times 10 to the 3 newtons. Very nice. Excellent. So remember, this is all based on what we did last year. You have to go back and think about all the things we did last year, how forces interact.